we started coronavirus research. That's 50 points, guys. Each one has been 10, 5, 10, 5. This one's 50. And I'm doing it with you guys, okay? If you have questions, talk to me and I'll help you. But we already saw the reason why. We saw a video of what's the reason why coronavirus happened. So it was bats. Bats happened, okay? So first it was the rats, then it was bugs on food, then it was birds, influenza, and then it's now bats, okay? So it was the rumor that somebody ate a bat, but you know what? Everybody around, so let's not judge because everybody have different beliefs in their culture, not beliefs, but traditions. Some people eat crickets, some people eat spiders, even grasshoppers and snakes. So there's people that ate a bat. So, but let's not judge, guys, because there's a lot of judging in the media, a lot like pointing fingers. That's not right, guys. All right, so coronavirus happened because of bats. And the second section was what are the long-term effects of coronavirus? So that's what were the long-term effects? Heart problems, energy, even similar symptoms like coughing and fevers. Okay, so we did that. We answered that last time, and today we're going to do how does the coronavirus spread? How does it spread? Very interesting section, guys. We're gonna be like, whoa, not even just COVID-19, but regular germs, how regular germs spread. Okay. Let me, okay. So the first one, how does coronavirus spread? Coronavirus new facts about infection mechanism. So this is a video. So we're gonna watch a video. It's a quick video. It's very interesting, guys, very interesting. And then we have to write what's the main point of the video. Let me see if I shared sound. No, I didn't. So let me pull it full screen. There is Japanese talking, but I'll talk afterwards. Okay. Subtitles, there's subtitles, guys.
Experts are now looking at this new infection mechanism as the key to preventing the further spread of the virus.
ただの会話の中で感染が広がっているとか、ある程度の距離があってもそれが広がっている、そういった事例を見ると、通常の飛沫感染だけでは説明できない、非常に小さな粒子ということで、マイクロメーターの粒子、マイクロ飛沫感染とも呼べるような、そういった状況が起きたんじゃないかというふうに考えます。
Micro droplets. When we cough, talk.
So how does this take place? NHK is conducting an experiment,
so they're making an
with
experiment
a group of researchers.
はい、データください。
The team will track particles in the air using laser beams and a high-sensitivity camera. This technology allows us to detect droplets as small as 0.1 micrometers wide. The experiment starts. First, sneezing. We can see a large droplet about 1 millimeter in diameter. It quickly falls. But let's look through the high-sensitivity camera. We can see small...
I mean, who sneezes like that? That's a pretty big sneeze. You have to be really sick to sneeze like that. But
particles that seem to glitter floating through the air. These particles are all smaller than 10 micrometers, or 1/100th of a millimeter in diameter. Let's take a look from a different angle.
Take a look at those particles. You sneeze, but they're still lingering in the air. They still stay in the air, those particles.
They're small and light. You can see them drifting through the air. These are microdroplets. We're learning that sneezing isn't the only source of these droplets.
バナナボートとか乗ったら楽しいですよ。
いや、絶対楽しい、
めちゃくちゃ楽しい。僕
We ran the same experiment on a close-range conversation. People generate a lot of microdroplets when they talk loudly. The droplets between these two stay where they are. They don't drift away. It's not yet known what volume of microdroplets leads to infection. But Tatada says we can't rule out the possibility that microdroplets have spread the virus to some extent.
そのマイクロ飛沫、小さな粒子の中にも
Microdroplets
たくさんの
carry
です
many
ね、
viruses.
生きたウイルスがいて、大きな声での会話、あるいは激しい息
We
遣い、
produce them when
そういった
talking
中でですね、
loudly
こ
or
のマイク
breathe
ロ飛
heavily.
沫ができて、それが近くの人、その人が吸い込むことによって、
People around us
感染が
inhale
広がる
them.
そういったリスクが見えてきたものと思います。
The risk of infection through microdroplets becomes even greater in a closed space with poor ventilation. This lab is simulating the movement of microdroplets in an airtight room. About 10 people in an enclosed space the size of a classroom. A person coughs once.
Imagine, guys, if we came back to school with this coronavirus happening. This is what would happen in a classroom. In an enclosed room, one person coughs or sneezes, that's it.
And spreads about 100,000 droplets. Large droplets are shown in blue and green. Most of these fall to the ground within 1 minute. But the microdroplets, shown in red, continue to drift. This simulation uses only microdroplets. 5 minutes later. 10 minutes later. 20 minutes later. The microdroplets are still floating in place.
空気がよどんでいる。
So guys, if we come back to school, yeah, we're not ready to come back to school. That would happen if we came back to school. Okay? Everybody's one person, it just takes one person to spread the whole classroom.
すると、つまり空気の流れがないということで、マイクロ飛沫そのものは、落ちたり、違う場所に動くことは
He's
でき
saying
ませ
if
んので、
the air isn't
長時間そ
moving,
の場所にとどまるということに
it
なります。
spreads around.
But there is a way to prevent this stagnation of microdroplets. Opening windows and increasing air circulation is believed to be effective. When you open a window, microdroplets are quickly swept away. They're very small and light, so any airflow will get rid of them.
できればですね、2箇所開けて風の流れを作ってあげるということが大事。それが1時間に1回でもいいから、
Create
そういうような
openings.
ことをやることによって感染のリスクっていうのはかなり下げることができるようになるんじゃないかなというふうに思います。
So being outside is less risky than being indoors, trapped inside. Even a supermarket, something like that. Like if you're enclosed somewhere, it's most likely you'll get the virus, and you might not even get the virus. But I mean, you might get it, but show no symptoms, and then pass it on to somebody else. Okay, so let's answer the first one. Um, what was the main message of the video, guys? What was the main message of the video? I already wrote it down for my other class, but what do you guys say? What's the
I
main?
think it mainly shows how the virus can be
Yeah,
spread.
yeah.
How long
Micro.
does it stay in the air?
Oh, yeah, very good. So it stays in the air. The microorganisms stay in the air for a long time, and okay, and it spreads easy in an enclosed area. So I already wrote it for my other class. The main message of the video was the importance of wearing a mask by showing how microorganisms spread when sneezing, coughing, and talking. That was my answer, okay? But you can write your answer, please. Write your answer. Okay. So full sentence, please. Just one full sentence is enough. Just give me the main topic, the main purpose. All right, so that's number one. Now, number two. Simulation shows how cough can spread coronavirus in grocery stores. When you go to the market, I'm going to go to the grocery store right now. And if I don't wear a mask, this is what's going to happen. Let's see what happens in a grocery store. So here's a simulation, a 3D simulation. And then we're going to read the article. Just skim through it. Just skim through it, guys, not read it complete. Let me do it full screen. So in a 3D model, a person coughs in a corridor bounded by shelves under. So basically somebody coughs and they're trapped in between the shelves. There's no airflow, no airflow. As a result of coughing, an aerosol cloud. So a cloud travels in the air of germs, not just COVID-19 germs, but any germs. Maybe he has a flu, regular flu. That's just him coughing, a person coughing in the store. And look, it's staying there for a while. It's not going away. Imagine walking into that germ, into the germ cloud. So not just COVID-19, but all germs, guys. So I'm thinking even after COVID-19 is over, wearing a mask once in a while is pretty good idea. So let's skim through the article, guys. San Francisco research in Finland have revealed shocking simulations that apparently show how respiratory droplets from just one cough in a grocery store can linger in the air for several minutes. That is very important, guys. Several minutes. So somebody coughs, they go away, they're still there. The cloud's still there. And then you probably walked in front of that cloud. So, and travels across 2 aisles, possibly infecting other shoppers nearby with coronavirus. So guys, wear your mask. Tell your families to wear masks. A lot of people don't like wearing masks, but it's very important. You might not get sick, but your family might, okay? Especially elderly or somebody that's already sick. Okay? Just skimming through it. Particles released from respiratory tracts when coughing, sneezing, or even talking. Coughing, sneezing, and even talking flow through the air. So just talking can spread coronavirus. Preliminary results indicate that tiny particles carrying the coronavirus can linger in the air for longer than originally thought, reinforcing the importance of completely avoiding crowded spaces or at the very least, follow social distancing guidelines. Well, again, guys, social distancing is good, but wearing a mask is better. Because like in the other video, it says even in a trapped room, you'll still get everything. Even if you're 6 feet apart, doesn't matter. You'll still get something in a closed room. So just wear your mask, guys. Wear your mask. And cloth masks. If basically if somebody's talking, they're not wearing a mask, the germs will stick in my mask. The germs will stick in my mask, and I might forget, and then I put it in my mouth or something like that, and I'll get the germs. So I like cloth masks, but remember to wash them, okay? Honestly, I don't wash mine, but I make sure that to wipe it off. You know, just be careful with that. All right, guys, let's answer the question. So what was the main message of the article? So the main message, guys, they're talking about the supermarket. When you're in an enclosed room, you can spread to other aisles. And the main part was that a cloud of germs sticks around for a couple minutes. Okay, that's the main point of the article, that there's a cloud. Even if it's not COVID-19, that's nasty, guys. Just a cloud of germs. You don't know what kind of germs they are. Maybe it's just the flu or a cough. You know, since I started wearing the mask, I haven't got sick, like not even regular sick. And it's helped me. So what I wrote for my other class was respiratory droplets from just one cough in a grocery store can travel and stay in place for a couple of minutes. That's what we wrote in the other class. I'm just showing you guys, okay? So make sure to write something about the article, please. I'm just showing an example. All right, guys, so number 3, let's do number 3. I don't want to keep you guys long, that's why. Look at this, guys. Why in times of COVID-19 you should not walk, run, bike close behind each other unless you're wearing a mask. So even look at him. He's running. He's like, all that breath. The guy behind you is getting it. Maybe you're the guy behind. All that person they're getting all that air. So for those that play sports, you know, just wear a mask right now, at least right now. Okay, let's skim through this, guys. What is the safe distance when running, biking, and walking during COVID-19 times? Is it further than typically 1 to 2 meters? That's 6 feet apart. As prescribed in different countries. Okay, is 6 feet apart enough, guys? No, we're learning that 6 feet apart is not enough. It's better to just cover your, maybe 6 feet apart plus the mask. Now that's safer. Because, you know, particles still travel out of your mask through the sides. Okay. Information, skimming through it. Okay. In a lot of countries, walking, biking, and jogging are welcome activities in times of COVID-19. However, it is important to note that you need to avoid each other's slipstream. Slipstream, what's a slipstream? A slipstream is when the person in front of you that's walking and running, they're creating a stream of air that they're breathing out. That's a slipstream. And that air may contain viruses, may contain germs, okay? This comes out of result of, okay, the typical social distancing rules many countries apply between 1 to 2 meters seems effective when you are standing still inside or even outside with low wind. So even outside, remember the other article was if you're outside, it's less likely you'll get the germs. You'll still get some though, if somebody's running in front of you. Okay, I used to run track. And when I was in high school, and I mean, there was people always in front of me running, and I probably got all that. I breathe in all that from the guy in front of me. So, and that's how we get sick. A person running behind you in the so-called slipstream goes through his cloud of droplets. A person running behind you in the So if I'm running and somebody behind me, they're going to get all my breath, all of it. Okay. The researchers come to this conclusion by simulating the occurrence of saliva particles of persons during a movement, walking and running. And this form different positions next to each other diagonally behind each other and directly behind each other. So look at that. There's a picture, guy's running, and this guy's behind him. He's getting everything, all those the sweat particles, the breath particles, everything. Okay. So right now, wear masks, please. When you play sports, a lot of my students say that they come to school to play soccer and other sports. So just wear your mask and you'll be fine. Okay, outside with the mask, you're good to go. Okay, so I think we have enough information to answer the question. Okay, so what was the main message of the article for number 3? What is the main message, guys? Remember what we talked about? Slipstream, person in front of you, you're walking, you're running, sports, just wear a mask. So I wrote something for my other class. Let me just show you as an example. We wrote, the article talked about when running and walking behind people, you will catch the air particles that may be infected, called a slipstream. Let's, where is it? Where is that word again? Very interesting. Slipstream, called a slipstream. Called a slipstream. So that's my example, guys. Just one sentence is enough, guys. One full sentence. Okay, let's do number 4 now. Let's do number 4. We're almost done, guys. We're gonna do attendance after we're done with this, okay? Almost done, guys. Almost done, almost done. Okay, article. 4th article. Even asymptomatic people carry the coronavirus in high amounts. What does asymptomatic means? Huh. I highlight it and I'm going to search what it means.
Are people that that are immune to the virus.
Well, actually, Brian, it means a person that doesn't show symptoms. So they don't show symptoms. So probably they have it, but they're not showing the symptoms. So it's okay. Thank you, Brian. Thank you. Thank you. So asymptomatic person is somebody that's not showing symptoms. Okay. So even asymptomatic people carry coronavirus. So the title says that even people that don't show symptoms carry coronavirus in high amounts. So they will spread it. Like most likely kids, they don't really, they don't show it because they're healthy. And they don't know it and they're spreading around. Researchers in South Korea found that roughly 30% of those infected never developed symptoms, yet probably spread the virus. 30% infected never developed symptoms. So maybe I have corona right now and I don't know it. Maybe you have it and you don't know it. And that's how you spread it around. I'm going to tell you guys, my family all had coronavirus because they didn't know that one person had it, so they kept spreading it around. But I locked myself in a room. I quarantined myself away from them, and I never got coronavirus. So if you are, if you have it, stay away from people, please. Lock yourself in a room and everybody will be safe. And if everybody else has it and you don't, you should do the same. Lock yourself in so you won't get it. I never got it. Okay. All right, let's skim through this, guys. Of all the coronavirus qualities, perhaps the most surprising has been that seemingly healthy people can spread it to others. So you might seem healthy, but you can still spread it. There's a lot of people that are like, no, I'm not gonna wear a mask. I'm not gonna get the vaccine. Yeah, but you're only thinking about yourself. You're not thinking about others. Think about others, guys. Others. Okay? You might not get sick, you'll be safe. But what about your family? Maybe somebody has diabetes or something, and that will trigger their coronavirus. That's what we don't understand, a lot of us. This trait has made the virus difficult to contain and continues to challenge efforts to identify and isolate infected people. So people don't isolate themselves because they don't know they have it, you know? So please wear masks, guys, wear masks. And most of the evidence for asymptomatic spread has been based on observation. A person without symptoms nevertheless sicken others, or elimination. A new study, it is important data that's for sure, said Benjamin okay. It doesn't confirm what we've suspected for a long time, that asymptomatic cases can trend. All right, guys, so this is a short article. And so the main point of this is that people that don't show symptoms can still spread coronavirus. That's it. Easy. So that one is people that don't show coronavirus, they're asymptomatic, can still spread the virus, just as people that do have it. Symptoms can include coughing, fevers, and what did I write for my other class? I wrote 30% of people infected don't develop symptoms. People without symptoms carry just as much COVID-19 virus as those without symptoms. That's what I wrote for my other class, okay? So you write your own, guys, in the full sentences, please. Last one, guys. Almost done. Last one. Last one, guys. And this is a last article. What is the article called? New evidence suggests young children spread COVID-19 more efficiently than adults. So kids can spread COVID-19 better than adults. Ooh, that's interesting. How? Why? Last article, guys. 2 new studies through 4 different parts of the world have arrived at the same conclusion, that young children not only transmit SARS-CoV-2 officially. Okay, look, guys, SARS. Last time we saw a video that COVID-19 started with SARS in 2002. And then 2012, it went to MERS. And then it became COVID-19 in 2019. Okay. So that's another name for the COVID viruses. Okay. SARS. Efficiently, but many major derives. The first, which was published in, the Chicago study examined the concentration of SARS in the nasopharynx. Is that how you say the word? Nasopharynx? Let me see. Read out loud.
Nasopharynx.
Nasopharynx. So I had the computer read it for me. Nasopharynx. Or the upper region of the throat that connects to the nasal passages of children and adults. According to the results, children, look guys, according to the result, children 5 years and younger who develop mild or moderate COVID-19 symptoms have 10 to 100 times as much SARS-CoV-2 in the nasopharynx as older children and adults. So the article saying that kids that are little kids, 5-year-olds, can have as much virus inside of them than an adult, as much as an adult. So they might not even show it. They are, what was the word again that we said right now? asymptomatic. Yeah, you were gonna say it? Yeah.
Yeah.
Yeah, so a kid that's asymptomatic they can have as much virus as an adult, even though they're smaller. All right, so that's it. So what is the main message of the article? So the main message is small children can be asymptomatic and carry as much coronavirus inside of them as an adult. Done. Easy. Let me see what I wrote from other class. Children can carry the same amount of COVID. Children who are asymptomatic can carry the same amount of COVID-19 virus as an adult, even if they show no symptoms. Okay, I just repeated myself. They will spread the virus. They will spread the virus by talking, coughing, and playing. Easy. So that's it, guys. So make sure to do it on your own, guys. I just gave you some examples. We did it on our own. So today was how do coronavirus spread? So careful with those germs. Even after COVID-19, I'm still wearing a mask. And I'm going to do attendance now, guys. Guys, don't forget that you can still do old assignments. Grades are due in a week or two. Okay, I'll let you know. So let me do attendance.